Hello everyone, welcome to my second lecture, which is about characteristics of remote sensing image. So this is our second lecture. So as we continue our second lecture, we will get this what to consider when selecting satellite imagery. So there are a lot of issues one needs to consider before selecting a satellite imagery. So as you can see from this picture, most of the time we get good quality satellite imageries, and some other time we get poor quality satellite imageries. So what are the factors that make some imagery of good quality and that make other imagery very poor quality? So there are a number of factors that should be considered. One of the factor is sensor type. The sensor type will determine the type of the satellite imagery. So there are two types of sensors, active sensors and passive sensors. When we say active sensor, we mean the sensor is not dependent on external source of energy, but the sensor generates its own electromagnetic energy to illuminate the target. So the name active comes from the fact that the remote sensing system generates its own energy to illuminate the target. But the name passive tells you it doesn't generate its own energy to illuminate the target. So there are passive sensors as well as active sensors. So these sensors will determine the nature of the satellite imagery. Passive sensors usually do have high spatial resolution, while active sensors usually do have very coarse spatial resolution. So the sensor type will matter. And the other factor that determines the quality of the satellite imagery is the platform type. The platform type, means it is a device or it's a material on which the sensor is placed, is platform usually. So the camera or the sensor may be placed on airborne device or spaceborne device. If it is airborne, it could be unmanned aerial vehicle. They are called UAV or drones. So the camera may be mounted on aircraft. So these are called airborne remote sensing systems. So usually airborne remote sensing system fly very closer to the Earth's surface. The satellite imagery from these airborne systems usually have high spatial resolution. And another platform type of remote sensing is spaceborne. That means if it is a spaceborne remote sensing system, the platform is usually satellites. Okay, so satellites are just platforms. Okay, so the remote sensing type is satellite remote sensing system, usually placed in space, very high altitude from the surface of the Earth. So as compared to the airborne remote sensing systems, satellites or these spaceborne remote sensing systems usually have very low spatial resolution in comparison with airborne systems. So the platform type will also determine the quality of the imagery. Another issue that needs to be considered in selecting imagery is the type of orbit on which the satellite is placed, whether the orbit is sun-synchronous or geosynchronous. The name sun-synchronous tells you that the motion of the satellite is synchronized with the sun. And geosynchronous means the motion of the satellite is synchronized with the Earth. So in sun-synchronous orbits, the satellite rotates the Earth from north to south. So these are usually called near polar orbits, while geosynchronous orbits they remain stationary with respect to the Earth's rotation. So these are usually spy satellites, and the purpose of these geosynchronous satellites are for meteorological and communication purposes. So in sun synchronous, the purpose of satellite is Earth observation, while for geosynchronous satellites, the purpose is for meteorology and communication purposes. So they usually situate themselves very far from the Earth for geosynchronous satellites, while sun synchronous, they are situated usually very closer as compared to geosynchronous orbits. And another important issue that we should consider is the resolution types. There are different resolution types which determine the quality of your imagery. One is spatial resolution, the other is spectral resolution, temporal resolution, and radiometric resolution. There are 4 resolution types which determine the quality of your imagery. So we will come to the resolution type lecture later in this specific slide. So we'll continue. And another factor when selecting imagery is satellite program history. Some satellite programs do have, long history, while some others do have very short history. They started, there are satellites which are with old history, and there are satellite programs which started their program very recently. So if you want to know change detection in urban area, change detection in agricultural area, change detection in wetland area, for the past 40 years, for example, you need the longest running satellite program. You should go for the longest running satellite program, that is Landsat program. So if you want to know the change over the last 40 years, you should go for Landsat program. You have no other option. While if you need the recent satellite imagery, you should go for the recently launched satellite programs. So the satellite program history matters in selecting your need with respect to satellite imagery. And another issue is the capability of stereo viewing. It all depends on your purpose. Stereo viewing means this type of imagery will allow you to extract 3-dimensional terrain characteristics by having stereo pair imageries. Okay, there are some satellites with this capability. So if your interest is extracting terrain characteristics such as digital elevation model, slope, and the like, you will be, you will require those satellite imagery which can provide you this stereo viewing or stereo pair imageries. Okay. Another issue is price and licensing. You may have, or you may obtain a very good quality satellite imagery, but you might, end up in, in buying those satellite imagery with a significant cost. So price and licensing matter sometimes. And there are some satellites which are very available publicly, free of charge, and there are some satellites which are very commercial. So for developing countries, most satellite imageries are not affordable to developing countries' researchers. So this is another issue that we need to take into account. And another issue is processing options. Some satellite imagery requires huge, skills, skills in processing the data, skills in removing the errors and the like. So these processing options also matter. But some of the major factors one needs to consider in selecting imagery is the type of sensor, the platform type, and the orbit type and resolution type. These are the factors, okay? So when we come to types of sensors, what is sensor actually? Sensor is a device that measures and records electromagnetic energy. The natural sensor, an example of natural sensor is your eye. Your eye acts as a sensor. It is a natural device, we can say. It's a natural thing that measures, records electromagnetic energy. So sensors could be passive and active. Passive sensors are, as I told you earlier, they depend on external source of energy, usually the sun. So as you can see from this picture, passive sensors usually depend on external source of energy such as sunlight. The reflected signal goes to the sensor, okay? So without the presence of this sunlight, this sensor cannot record reflected signal, while active sensors usually generate their own energy and receives the backscattered signal from the reflected ones. So these are, say, active sensors and passive sensors. What are the examples from passive sensors and examples from active sensors? What type of imagery do you know from passive sensor and active sensors? Passive sensors can also be classified into three depending on the spatial resolution: low resolution, moderate resolution, high to very high resolutions. The distinction of this may not be determined in a very strict manner, but the commonly applied distinction between low, moderate, and high is applied for satellite imagery with spatial resolution greater than 60 meters considered low resolution, moderate from 10 to 30, high less than 5 meters. And those satellite imagery from passive sensor grouped under low resolution are MODIS, SPOT, and moderate Landsat, ETM, TM, and Sentinel spot usually considered. And high to very high, quick bird, orb view, spot, corona, satellite imageries can be grouped in passive sensors. And what type of image can be grouped in active sensors? Radar and LiDAR imageries. From radar, we know RadarSat, ERSSat, NVSat, Space Shuttle. This is the type of imagery which provides digital elevation model. And there are also LiDAR imageries. These are airborne platforms. And the only spaceborne platform for LiDAR is IceSat data. Okay? And the type of platforms in remote sensing are, they depend in altitude in which the satellite is placed. There are ground-based remote sensing, low altitude remote sensing, high altitude, and satellite remote sensing. So platforms for remote sensing may be grouped depending on the altitude. So this is how the satellite takes picture or captures imagery. So the point that is found directly beneath the satellite is called nadir point, and there is the incident radiation from the sun, and the angle between the two is called solar zenith angle. And the type of orbit in remote sensing, there are two types: geosynchronous orbits and sun-synchronous orbits. As you can see from the picture, the orbit, the satellites which can be mounted on sun-synchronous orbits are near polar orbits. They revolve around the Earth from north to south, while geosynchronous orbits, these are spy satellites. Their purpose is for meteorological and communication purpose, and they situate, they are situated most of the time like this, so very far from the Earth, so they remain stationary. So this is the direction. So satellite positioned in geosynchronous orbit revolve at an angular rate that matches the Earth's rotation. So it follows, so they remain stationary with respect to the Earth's surface. So example, meteorological and communication satellites for mobile purpose. And sun-synchronous orbits are satellites in these orbits are synchronous with the sun. This means they are synchronized to always be in the same fixed position relative to the sun. They follow the position of the sun. So That is why, because the system of taking picture in such orbits is dependent on the solar radiation because they are passive sensors. So with regard to the type of resolution in remote sensing, what type of resolution do we know? The first type of resolution that is commonly known is spatial resolution. It is a measure of the smallest object that can be resolved. So it's all about the smallest area on the ground represented by each pixel. So as you can see from the picture, in Landsat 8 with 30-meter resolution, it is very difficult to identify a tennis complex in London. But if we increase the spatial resolution into 10 meters, we start recognizing the object. If we increase the spatial resolution into 3 meters, we start recognizing it very well. If we again increase the spatial resolution by this much number, 0.3 meter with a high spatial resolution, now we can recognize the tennis complex in Wimbledon, in London. So this is the effect of spatial resolution. So the finer the spatial resolution, the lower the number, the more detailed the record is. So we generally stick to the following subdivisions: low resolution data, medium, and very high resolution data. And the second resolution type in selection of satellite imagery is spectral resolution. The word spectral is related to specific wavelength interval. If you are telling me that it is a spectral resolution, then I know immediately that you are referring the specific wavelength interval, whether it is coarse or whether it is fine. If you have wide intervals wavelengths, then you are referring to coarse spectral resolution. Take a look at this example. When I say black and white imagery, since the wavelength range is very broad, then there is no further distinction in color, then this is a wide interval and coarse spectral resolution, and hence the color is black and white. When we start, disintegrating this whole color into blue, green, red, now we start bringing the concept of color by making the spectral resolution very finer, blue, green, red. We can also make the blue into further disintegration, and we can call it hyperspectral imagery. So when we have narrow bands, we will be able to distinct objects. We will be able to discern objects, identify objects. We can easily identify objects. We use hyperspectral imagery normally for identification of species. For example, if you want to identify Eucalyptus globulus from Podocarpus plantation, you can easily identify it through hyperspectral imagery. You cannot identify through multispectral imagery. So if your purpose is species identification, for example, if you want to identify different species plantation, okay? If you go to, for example, Afar region, there is expansion of, what do you call this, Yawayane Zaf. So how can you identify, this species from the normal woodland and shrubland? You can use hyperspectral imagery for its identification. Another important issue is temporal resolution. It refers to how often a sensor obtains imagery for a particular area. So does the sensor takes imagery of an area every week, every 2 weeks, every month, every year? So in this case, I am referring to the temporal resolution. So temporal resolution is determined by altitude and orbit. Okay, most of the Earth observing satellites usually have coarse temporal resolution, 16 days, 14 days, 26 days. If you look at Iconos, Landsat, they do have 16 days. If you look at meteorological satellites, such as meteosats, they do have high temporal resolution, such as 15 minutes, okay? Because meteorological satellites usually need to monitor or need to provide data on the meteorological condition of a certain area with fine temporal resolution. So that's depending on the purpose and the orbit type. Yeah? The meteorological satellites usually are situated in what type of orbit? In geosynchronous orbit. So temporal resolution usually matters. Okay. And another important issue is radiometric resolution. So it refers to the ability of a remote sensing system to discriminate very slight differences in energy. So radiometric resolution normally specifies how well the differences in brightness in an image can be perceived. This is measured through the number of the gray value levels. So the maximum number of value is defined by the number of bits. If an image has 2 bits, the number of gray value levels can be determined by the equation 2 to the power of n. N refers to bit. So 2 to the power of 2 is 4. So this type of imagery will have 4 levels of gray levels, brightness values. So this type of imagery, 2 to the power of 4 is 16. So this imagery will have how many levels of gray value? 2 to the power of 4, which is 16. 16 levels of brightness value or digital number will be manifested in portrait through this imagery. What about this 2 to the power of 8? This is 256 level. This is an imagery with 8-bit imagery. The radiometric resolution is how much? How much? It is 2 to the power of 8. It is about 256 levels of gray level. That means brightness values. This much brightness value. So the objects that can be identified in 2-bit, 4-bit, 8-bit will differ depending on the radiometric resolution. So a satellite imagery with higher bits are normally high radiometric resolutions. Okay. So coming up next is lecture 2.2, which is about Earth resource satellite programs.